In this video, I'm going to demonstrate using a step block with 5 different thicknesses of material to calibrate an ultrasonic flaw detector. I'm going to be using a Sonatest wave unit. It's a digital ultrasonic flaw detector shown here. And for probes, I'm going to be using a pulse echo probe. So it's a single transducer pulse echo probe. It's a model V112-10/0.25. And this is a 1/4-inch diameter transducer designed to run at 10 megahertz. It's a direct contact, so it will contact the part using a couplant gel to acoustically bond it with a micro dot connector, which is a very small threaded coaxial connector. The test block I'll be using is a step calibration block from Olympus MDT. It's part number 2213E. And it's made of 7075 aluminum, and it has 5 step thicknesses on it of 100 thousandths, 200 thousandths of an inch, 300 thousandths, 400 thousandths, and 500 thousandths. If we switch to a view of the tester, we're going to see this screen when we first boot it up. And for this demo, I'm going to use the 3655 class configuration menu. And so we can go into the default configuration by going in touching that screen. Going on this screen, I'm going to have default configuration. I'm going to press the launch button in the lower right corner. And it's going to bring up a view of what I'm going to set up. And so I'm going to start by pressing the signal button here. And this brings up the different menus, the different control menus that I have. And so you can see here we have signal. There's some adjustments we can make to the signal, the display, different alarms, and then gates 1 and 2. And then finally, main is where most of our setups can take place. So I'm going to start with main. The default velocity given here is 0.2700 inches per microsecond. I'm going to leave that where it is. Even though we're going to be doing an aluminum block, and aluminum typically is somewhere around 0.2500 or 0.2490. I want to leave it a little bit off so I can demonstrate the calibration procedure and have it be a little more, show it a little bit more. If I actually start too close to the actual known velocity of aluminum, it's possible that I won't need to be doing much in the way of calibration at all. Our probe 0, remember the probe itself, the transducer inside the probe is behind a wear plate, so it's not right up against the material. And so the probe 0 allows us to set essentially how long it takes for sound to get from the transducer, the piezoelectric transducer inside the probe to the surface of the material. We'll set that after we get velocity dialed in. So we're gonna leave velocity. That's this one here for now. Probe 0, we're gonna leave that at 0 right now. Range we want to set based on our part. So if you look at the bottom of the screen right now, it runs from 0 to 5 inches. And the step block we're doing, the largest step is 0.500 inches. So we're only worried about the first ½ an inch of the screen that's shown here, which is a very small portion. So to get better resolution of the area we're looking, we're going to change our range. There's a couple ways we can do it. The first off is there's some pre-selected ranges given here on the left. You can see I've changed it between 1, 2, 5, or 10 inches. But none of those quite go to the range we want. I can up those ranges if I want. If I'm at 1 and I do +1 plus, I can do by 1 inch, or I can do by 1/10 of an inch increases and decreases. Or a third option I have is I can bring up this keyboard and I'm able to punch in a number. So I'm going to do 0.6, just a hair bigger than what we're looking at. So after setting my range of selecting 0.6, I'm going to hit OK to confirm that. And so now my range is set. The next item is delay. And I'm not using a delay line probe, so I'm going to leave that at 0. If we were using a delay probe, we'd have to set that. Angle's the same thing. We're not using an angle probe. This is a pulse echo probe, so it's a 0-degree angle. Frequency, I need to match the probe. And this is, as I mentioned in the intro, this is a 10 megahertz probe, so I need to adjust that. And you can see 10 is not one of the quick options on the left. And so I'm just going to go ahead and type in 10 and hit OK. The probe width, this is a 1/4 inch diameter, so this is one of the quick options, 0.25, and hit OK. Transmit, and I can drag this menu up and down using my finger. Transmit mode, transmit receive mode. We're going to do pulse echo, so I'm going to leave that, but through transmission and pitch catch can be used with a pair of transducers to do through transmission. And then we get down to something called envelope. An envelope is kind of a memory function. So if I put my probe on a piece, you can see I get a peak here, but as soon as I take it off, it goes away. If I turn on envelope, the first one is called peak memory. And so now you can see as I go to different steps, we get peaks. Now, one thing you'll notice is these steps are 0.5, 0.4, 0.3, 0.2, 0.1 inches. You can see all of these are not showing up in the correct spot, and that's because we haven't finished calibration yet. Once, if I have peaks or if I have indications here I want to clear, I can hit the reset envelope button and that'll make them go away. Another option is what's called trail. And now it's a peak memory, but it's a temporary one. So as I go along and I make these, you see we'll get the same thing, but then they start to drop off over a set period of time of about 4 seconds away. I can reset it as well. I'm going to leave this off for the time being. Down at the bottom is for editing the part, and that is used if you're going to do angle beam testing, or if you are going to use, instead of the A-scan layout, if you're going to use scan plan, this is how you edit the part shown here. So right now, if you look at the screen on the left, it's been changed to a distance. It's showing 0 to 1 inches deep, even though our part is only a 1/2 inch deep. In that case, what I would do is hit edit part. And this is a piece of flat metal. You can also have like different joints, corner joints or curved pieces. We're on a piece of flat metal. Ours is a 1/2 inch thick. But again, it doesn't really make a huge difference for ours because this really is more important for angle beam or if you're trying to visualize it. And then whether there's a weld or not. And this is non-welded, but you can put in a weld. And then I hit exit. And so now it creates a part that, you know, if I was testing this, we can look for flaws at different depths. And we can say, oh, wait, no, it's over here. We can move this as we move our probe across the part. But we're not going to use scan plan. We're going to stick with A-scan now. Okay, so I have now set my frequency, my probe width. I've left some of the other stuff zeroed. I've set my range to match the thickness of the part that I'm testing. Now I can begin to set my calibrate my velocity and my probe 0 point. For this though, I am going to turn on a gate. So I'm going to hit my main button, I'm going to hit gate 1, and I'm going to enable gate 1. And here you can see a red line has popped up, and this is a gate. And so it can be for a couple things. One is it can be tied to an alarm, which are the rectangles across the skinny rectangles across the top of the screen. You see one of them is a light red now, the others are black. And I can, that's the alarms menu, I can adjust those, but the start is where the left side of it is. So as I go up and down, you can see I can move the left side, but it stays the same width. Or I can type in a start point if I want. The width is the overall width. So now if I make this bigger or smaller, you can see it changes, you know, it doesn't change the start point, but it changes the end point. Or I can type in, say I want it to be 0.2 inches wide. The level is where it is on the screen. So if I go +10, it goes up or down, and what it is, it's percent of full screen height. And that's based on the amplitude of our return signal. I'm going to leave it at 70% here. Polarity, positive. That has to deal with using it for an alarm function. If it's positive, it's going to trigger the alarm when a peak crosses that gate. If it's negative, it's going to trigger an alarm when a peak is not crossing the gate. So if I change that to negative, actually I've taken negative out of this one. Now, one other thing we can do with the gate, if I tap it, you're going to see I get arrows on here. And so now I can actually tap the left arrow to adjust the start point. Okay. I can tap the right arrow to adjust the end point independently. Or I can tap the center box to move it up and down, as well as left and right. Now, it'll only let you do one at a time as we do this. If I double tap on it, it zooms the screen into that area of interest. So, and then I can hit reset zoom at the top left to go back to this. If I tap off of it, it's no longer bold. So I'm going to reset my start. I'm going to put it at 0.1. And I'm going to, actually I'm going to go 0.05. So because remember our step lock goes from 0.1 to 0.5. I'm going to make the end of 0.55. So it goes a little bit, oops, sorry, I did the start point, 0.05 for my start point. I'm going to make the width, the difference between these, the biggest one is difference of 400,000. So I'm going to be 0.450. Make sure I cover all the way up to a little past 0.5. Let me make it a little bit bigger, actually. 0.4. If we do 0.50, there we go. And then my level, I'll leave at that 65 or 70% full screen height level. Now I can, like I said, my alarm now is enabled. You can see if I turn that off, that box at the top goes away. I could turn it on. And my source is gate 1. You can also set alarms for gate 2 or other things there. Now what you'll notice is at the top of the screen, these things labeled gate 1 with a peak here. This button right here is now available. And this is telling me it will tell me what the height, full screen height is of my peak that's on gate 1. So I'm going to leave that one how it is. Gate 1 with this arrow here, this is the peak and the sound path, or how far the sound is from the front wall, from the 0 point. So I'm going to leave that so I can use that to measure distances. Back to main. So now I can begin checking my part. And what I want to do is pick two steps that have some distance between them. So I'm going to do 2,000ths and 5,000ths. And to start with, I'm most concerned about the distance between any two steps. So here is the 2,000th step. And you see I have a primary echo. That's the tall one with the little red dot. The red dot's forming at the top because that's what's triggering the alarm right now. I have a second echo right now between 0.4 and 0.5. That's a secondary echo. So that's where the sound's coming back up to the front and then going back to the back wall again, then back up to the sensor. So that's kind of irrelevant. But you can say this is it's telling me that it's at 0.239, so it's 39 thousandths off. But we want to remember that 39 thousandths. If I go up to 5, I gotta extend my gate a little bit. Okay. Now it's telling me my 0.5 is 0.566, so it's actually telling me that these two steps, which should be 4 thousandths apart, 400 thousandths apart, it's telling me they are more than 400 thousandths apart. In fact, to figure that out, if we take the further one here, so 0.566, and we subtract from our 0.2 here, which is 0.239, it's 0.239, 0.566. It's telling us it's 327th, and they should only be 300 thousandths apart, right? Normally, if you take 5.5 minus 0.2, you should get 0.3. So it's telling us that that step difference is 27 thousandths more than it is. What that means is our sound velocity is off. And so the way we can adjust that is I go to the main menu and I tap on velocity. Okay. And when it's too high, when it's telling you the distance between any two steps is too high, you need to turn your velocity down. So I'm just going to turn it down in increments. We can kind of see what happens. So that first one, it was telling us the distance between those two was 27 thousandths too much. So I'm going to drop this. Instead of 0.2700 inches per microsecond, I'm going to go 0.2600 inches per microsecond. And now let's see where we end up. So we were at 327 thousandths before. Let's see what it becomes now. So if we take our peak, you can see this has moved now. It's 0.545, 0.545. And we're going to subtract the 200 thousandths height from it. 0.230 gives us a difference of 315 thousandths. So it's closer. We want it to be exactly 300 thousandths, but it's still not there. Remember, before we were about 27 thousandths off. So now we're closer. So that means we still have to lower our velocity some more. So I'm going to, let's try to bring it down to 0.2500. Now this is the recommended starting point for aluminum. So we're at the recommended starting point for aluminum. I'm going to hit OK. Now if we're at the recommended starting point for aluminum, I'm going to clear this. I'm going to go to my 0.5 section. And now you can see we're at 0.524. And then our 200 thousandth point is coming in at 0.221. So now you can see we're within 3 thousandths of the correct distance between our 200 thousandths and our 500 thousandth step. So that means we need to bring the frequency down, or velocity down, just a little bit more. I'm going to go back into the velocity menu. Now I can use the kind of the steps rather than redoing it. So if I do 1/1000th, that's going to bring it down to 249. You can see now we're at, if we go to 500 thousandths, we're at 522. And if I go to 200 thousandths, I'm at 220. So you subtract that, that gives us 2,000. So we're closer, but we're still a little bit off. So why don't I drop it? Now we're at 0.248 inches per microsecond. Now it's showing my peak on 500 thousandths at 520. And it's showing our peak here at 219. So now we're 1/1000th of an inch off. So that means we can go a little bit lower. But I think if we go another 1,000th of an inch per microsecond, if we change the velocity, that'd be too much. So now I can start to use the finer adjustments. Let's take this to 2475 and let's see where we're at. 519 minus 219 gets us to exactly 300 thousandths. So again, if I punch this in, I'll show you with the calculator. I go to my 500 thousandths block, 0.519. I subtract my 200 thousandth step, 0.219. That gives us exactly 300 thousandths, and that's the difference between those two steps. So we have now calibrated our frequency, or sorry, excuse me, our velocity. But what's wrong here is both of these now are 20 thousandths off. They're 20 thousandths too far to the right. 19 to 20 thousandths too far to the right. So now I have to move my entire screen. I have to shift it to the left. And to do that, that's what I'm going to use the probe 0 for. And so one easy way to do this is just to couple my probe and hold it on a single point. So 500 thousandths here, it's 519. And now I can increase, right? Because we're increasing the amount of time it takes. We're telling the tester that it takes a little bit of time for that sound to get to my block. So I'm going to start increasing it in 5 thousandths of a microsecond. And you can see now we're at 518, 517. What if I did 0.2? What if I started at 0 and did 0.2? Oh, that's too far. It went 494. But I can back it off a little bit. 495, 496. You can see as my probe 0 is changing, we're getting closer and closer to 500 thousandths, which is where we're at now. So now if I go down my block, here's 500 thousandths, 400 thousandths, 300 thousandths, 0.300, 200 thousandths, and 100 thousandths, and they're all showing up exactly where they should be. So now we have calibrated our velocity as well as our 0 point. Now in your lab, what you're going to have to do is show these steps. So a way to do that is to go to envelope down here and do peak. And now I can show my 500 thousandths peak, my 400 thousandths peak, my 300 thousandths peak, my 200 thousandths peak, and my 100 thousandths peak. Another thing you'll have to do in your lab is measure the distance between these peaks. And what I can do is, one way to measure is if I set my gate, I'm going to bring it up a little bit, and I set each end of it, I set it to the tallest peak. So I'm going to put this right here, which is right at that tallest peak, at the 0.2 spot, and I'm going to compare it to the tallest peak at the 0.4. And now if you look at my gate 1 width, you can see is at 203 thousandths of an inch, which those are 0.2 inches to 0.4 inches is 0.2 inches total. Okay. So a picture of this, I could always take an image and call that my my measurement. Call that measure. Okay. If I want to get rid of the gate and just show the peaks, I can bring my gate menu up. I can disable it. There are my 5 peaks, for instance. There's our 5 peaks. And then from there, I can go make other measurements as I want. One last item to point out has to deal with our gain. And right now our gain was set pretty well at the default. But if you do turn this on and your gain set too high, what you'll get is something that looks like this, where peaks shoot off the top of the screen. Okay, if peaks are going off the top of your screen, that's way too high. We typically want our peaks to run somewhere around 80% full screen height. If our gain's turned down too low, you can see we don't get much of a peak at all. It's less than 20% of full screen height. And the problem with that is that smaller indications that may occur would be hard to find. So that's where we want to adjust our gain to get our indications at roughly 80% full screen height. That's why those 2 white lines are there. Okay, so 26.1, earlier we were testing at 25. Right? So that's how the gain adjustment is done too. We didn't really need to do it in this example. Other things that you might want to do, if you're testing a thinner part, for instance, we calibrate it. Now anything we're going to test, if it's in the 0 to 1 range, we can adjust our range. If we were going to continue to test something between 0 and 0.1 inches, we can adjust our range and it's not going to affect anything else. So now I'm looking at everything between 0 and 0.1 inches. There's our peak on the right from the 0.1 inches. And if there were any cracks or flaws in here, they would show up in this black blank space in the middle right here. So that wraps up calibrating an ultrasonic tester using a step block.